In this lesson, we're going to solve rational equations. So my first example, we have a basic rational equation. We have one rational equal to another. And the simplest way to dealing with this situation is to solve it just like you would with a proportion and cross multiply. So we could do that, just cross multiply. And what we'll have is 7 times 2x minus 10 equals 11 times x minus 2. Then we'll go ahead and distribute the 7, leaving us with 14x minus 70 equals, and then distribute the 11, which will give us minus 22. Go ahead and subtract 11x from both sides. So I have 3x minus 70 equals negative 22, and then I'll add 70 to both sides. And thus 3x is equal to 48. Divide by 3, and we get our answer, x equals 16. And then we box that in. Simple enough.
In example 2, we're going to solve for x. X is in the denominator. It's on both sides of the equal sign. So what I have here is 15 over x plus 4/5 equals 7 over x plus 2. And I could rewrite that as 2 over 1, which I want to do. Because what I want to do here is I need to cancel out the denominators. Okay, so we can't really work with this when the x is in the denominator like that. And to do that, we're going to cancel it out like we did with the complex fractions. We're going to find the least common denominator and then multiply both sides by that. So in this case, our least common denominator is going to be 5x, looking at all their denominators here. So I'm going to multiply this side by 5x, and I'm going to multiply try it again. Multiply this side by 5x, kind of like so. So what I'll have is, in essence, 5x times 15 over x plus 5x times 4/5. And then we're going to distribute the 5x over here on the other side as well. So I'll have 5x times 7 over x plus, or rather like that, plus 5x times 2. Okay, now I'll see that the x's cancel out here. On this one, the 5's are going to cancel out. And this side, the x's cancel out, and then here I don't have to worry because it's 2 over 1, or just 2. So when I rewrite this, I'll have 75 plus 4x equals, 5 and 7 gives me 35, plus 10x. And now we're just going to solve for x. I can subtract 10 on both sides, which is going to give me negative 6x, and I'll subtract 75 from both sides, which is going to give me negative 40. I'm going to divide both sides by negative 6, like so. That's going to leave me with x equals 40 over 6, which would simply reduce to 20/23. So x would be 20 over 3.
Moving right along, let's look at another one. This time we're going to take the same approach. We'll have to get a common denominator, except the difference is that our denominators are binomials. So we'll have to get a common denominator and then, or find what the least common denominator is, multiply, and then solve. And we're also going to have to check for extraneous solutions. When we start dealing with binomials as denominators, that's when we're going to have to start taking that extra step. So let's get right to it. Okay, so first I can tell that I'm probably going to need to factor. So I'm going to rewrite what I have here. 8x squared over, and then this is a difference of squares, so I have x plus 3 times x minus 3 minus, and then I have 4x over x plus 3, and looks like my common denominator in this case is going to be x plus 3 times x minus 3. So I'm going to multiply by that, x plus 3, x minus 3 on this side as well as the other. So x plus 3 times x minus 3. I'll just have to write it like that because I'm out of space. And the x minus 3's will cancel on this side. On the other side, well, let me write that out. So for now, I'll just write this one as 6 times x plus 3. This one's a little bit more complex, so let me just take the time to distribute this stuff. And then I'm going to have 8x squared over x plus 3 times x minus 3, and then minus, and then again x plus 3 times x minus 3, and then 4x over x plus 3. And I can see that on this one the x plus 3 and minus 3 both cancel out, leaving me with just 8x squared. And then I'm going to have just the x plus 3's cancel here. So rewriting this, I'm going to go ahead and distribute this. 6x plus 18 is equal to, and then we'll have 8x squared minus, I'll go ahead and distribute the 4x with the x minus 3, so that'll leave me with 4x squared minus 12x. So when I rewrite this, so I have 6x plus 18 equals 8x squared minus 4x squared plus 12x, distributing that minus sign. And let's go ahead and simplify and set everything equal to 0. So we'll be left with 4x squared when we combine the x squareds. I'll subtract 6x with 12x, which will leave me with just plus 6x. And then I'll subtract 18, leaving with negative 18 equals 0. Now I'm going to solve. So we'll have to start off by pulling out a greatest common factor. So I can factor out a 2, and that's going to leave me with 2x squared plus 3x minus 9 equals 0. And then this will factor further into 2x minus 3 and x plus 3, which equals 0. Finally, we can use the zero product property and solve for the x's. So 2x minus 3 is equal to 0, as well as x plus 3 is equal to 0. And then we'd have two solutions of, let's see, that's going to be 3 halves, positive 3 halves, and negative 3. However, we're going to have to check for extraneous solutions. So let's do that. So we'll start off with the 3 halves. We'll substitute that into the original equation. So I'll have 6 over 3 halves minus 3 equals 8 times 3 halves over 3 halves squared minus 9 minus 4 times 3 halves. Ugh, that's an ugly 3 halves. And then 3 halves plus 3. And then with a little mental math and the help of a calculator, we would come up with, hey, negative 4 equals negative 4, and that checks out. Cool, groovy, awesome. So that's a winner. But now let's try the negative 3. So with the negative 3, I'm going to have 6 over negative 3 minus 3 equals 8 times negative 3 over negative 3 squared. See, the squared's on the outside. Negative 3 is in parentheses since we're substituting it into there. So that would be the correct way of doing that. Minus 4 times negative 3, and then negative 3 plus 3, like so. But uh-oh, I notice we have a problem right away. I don't have to work this out because this is going to be 0, and you can't divide by 0. And look at this. This is also going to be 0. And once again, we're dividing by 0. Can't do that. The thing's broken. So negative 3 is going to be our extraneous solution. So therefore, our solution is x equals 3 halves with an extraneous solution of x equals negative 3. So anyway, there we have it. That is how you can solve rational equations. So until next time, I'll see you on the flip side.